In this video, we're going to graph linear inequalities. So if we're going to graph linear inequalities, we need to know what they are. And so far throughout this semester, we've talked about linear equations. And we know that linear equations, the linear part stands for line, and the equation part stands for this equal sign. So on the screen right now, you see two examples of linear equations. And all a linear inequality is essentially this same thing, but this equal sign is an inequality. And remember, an inequality is the less than, greater than, less than or equal to, or greater than or equal to symbols. So for example, we could change this first equation to a linear inequality by just putting a greater than symbol in place of the equal sign. Or, say for example, in the second one, we wanted to change that to a linear inequality as well. We can take the original equation and say we put a less than or equal symbol in there instead. So all a linear inequality is essentially the linear equations that we've been working with, but we just replace that equal sign with an inequality sign. So just like linear equations have solutions, so do linear inequalities. And because we have an x and a y in a linear inequality, our solutions will be points. So what we're going to do with the points below is we're going to test them inside of this linear inequality and see if they do work and they are a solution or if they're not. So for this first one, I see that x is equal to 1 and y is equal to 0. So if I take my linear inequality, I have 3 times 1 minus 2 times 0 is less than 8. Well, that would become 3 minus 0 is less than 8. 3 is less than 8. Yes, that is true. So the point 1 comma 0 would be a solution. Then if I try the next point, I have x is 2, y is negative 1. So I have 3 times 2 minus 2 times negative 1. Well, 3 times 2 is 6. And then this is really negative 2 times negative 1. So I have 8 is less than 8, so this is not a solution. So the point 2 comma negative 1 would not be a solution to our linear inequality. Then if we try the next ones, 3 times 3 minus 2 times negative 2. So again, keep, change. So I have 9 plus 4. So 13 is less than 8. That is false, so this one is also not a solution. And then last but not least, let's try out that last one. So we have x and y. So 3 times 0 minus 2 times 4 is less than 8. 0 minus 8. So I have negative 8 is less than 8. So 0 comma 4 is a solution. So what's great about graphing linear inequalities is it's actually very similar to graphing linear equations. There's just a couple of additional steps that we add in. So the first part to actually graph it is exactly the same as what we would do if we had a linear equation. Remember when we had linear equations, we talked about slope-intercept form, which is y equals mx plus b. And if we could get that y value alone, we would be able to identify the slope, which would be the coefficient of x, and we would be able to find the y-intercept, which was the constant added onto it. So what we're going to do is to start, we're going to get this y value alone, and essentially we're going to rewrite this into slope-intercept form. So I'm going to utilize keep, change there, and then subtract 4x, subtract 4x. So I have negative 2y is greater than 8 plus a negative 4x. Now I still need to get y all the way alone, so I need to divide both sides by a negative 2. Now I remember from when I solved inequalities that when I divide both sides by a negative, I need to flip my inequality. Sorry, that got a little messy there. Flip my inequality. So as I'm dividing both sides by a negative here, I note that I need to flip my inequality to be a less than symbol. So we have y is less than negative 4 plus negative 4 over negative 2 is a positive 2x. So this is my linear inequality rewritten into slope-intercept form. And now what I'm going to do is I'm going to apply my slope and apply my y-intercept to at least get points on that if that were a line. So my slope is the coefficient of x, which is 2 over 1, which means I'm going to go up 2 and right 1. And then my y-intercept is where I cross on my y-axis, and that's a negative 4. So I'm going to go to my y-intercept, which is x is 0, y is negative 1, 2, 3, 4. And then to find additional points, I go up 2, right 1, up 2, right 1, up 2, right 1, so on and so forth. Now don't plot a line just yet, just plot the points, because it's at this point that graphing linear inequalities is a little bit different. So remember, when we graphed equations, we were just graphing every point that made the equation true. And that's exactly what we're going to do here as we graph linear inequalities. So notice how I have the outline of what the line would be, those dots in blue are the outline of what it would be if we had an equation. Now, just like when we had one-step inequalities, remember when we had like x is greater than 2 and we would use an open circle, or x is less than or equal to 2 and we would use a closed circle. Remember how that circle communicated yes, 2 is a solution if we had a closed circle, and no, 2 is not a solution if we had an open circle. The line that we draw through those blue dots communicates the same exact thing. If we draw a solid line, that is communicating that the equals part is a part of that solution. So if we have a less than or equal to or a greater than or equal to in our linear inequality, we are going to draw a solid line, this solid line right there, in order to communicate that all of the points on the line make the equation or make the inequality true. And that's because it contains the equal to part. If we don't have the equal to part, like we don't in this particular example, we are going to use a dotted line. And what this dotted line means, so this is for the greater than or the less than sign, so there's no equal to part. What this means is that we have essentially a boundary. This is an important boundary, but the points on the line do not make the inequality true because we don't have the equal sign in our inequality. So here, because we do not have the equal sign as a part of this, we just have a less than symbol, we are going to draw a dotted line through these dots. And that dotted line communicates that this line is an important boundary line, but then it also communicates that the points on the line do not make the inequality true. So that is the first way that graphing a linear inequality is different. Now the second way in which this is different is that our points that make our linear inequality true are a little bit more. There's a little bit more to it. It's not just graphing that line onto our graph. So essentially, there are many points that will make this linear inequality true. And you can see here we have two regions on the side of the line. Here's region 1 up here, and here's region 2. We have a region above the line and a region below the line. And essentially, because of that inequality, one of those regions contains points that make the inequality true, and one of those regions contains points that do not make the inequality true. So what we're going to do is we're going to pick a point in each region, and we're going to test and see which region makes the inequality true. So here, if I'm up here, I can pick any point up here in region 1. I like to focus on the point 0, 0 because to me that's a really easy point to pick. So that's my point for region 1. And down here I need to pick a point in region 2. So I'm going to pick the point 1, 2, 3, 4. X is 4. Y is negative 1. Again, it doesn't matter. You can pick any point. You just need to pick one point in each region. So let's test out region 1. And in order to do this, we're going to go back and we're just going to utilize this original inequality. So here I have 4 times x, which is 0, minus 2, which is 0, is greater than 8. So here I have 0 minus 0 is greater than 8, or 0 is greater than 8. And that is false. That is not true. So that point does not make this inequality true. So now let's try region 2 and see if we have more luck there. So here I have region 2, and I picked the point x is 4, y is negative 1. So I have 4, comma, x is 4, minus 2, comma, y is negative 1. Use keep, change, change. So I have 16 plus 2. So 18 is greater than 8. And that is in fact true. So what I learned here by testing a point in each region is that these points up in region 1 do not make the inequality true, but these points down in region 2 do. So region 2 is the region, all of these points down here are going to make that original inequality true. So what I'm going to do is I'm going to shade that region and represent it as the region with the points that make the inequality true. So I'm going to take my pencil and I'm going to lightly shade it in. And by shading it in, what I'm representing is I'm saying all of these points make the inequality, so that inequality true. So now let's try another example together. Remember, we need to start by getting it into y equals mx plus b form. So I'm going to start by adding 6x to each side. So I have 3y is greater than or equal to negative 12 plus 6x. Divide both sides by 3, and I have y is greater than or equal to negative 4 plus 2x. So I'm going to then go to my graph, and I'm going to plot my y-intercept at negative 1, 2, 3, 4, and then go up 2 over 1, up 2 over 1, up 2 over 1, and continue that pattern going both directions. So there I have the dots for my line. Then I need to decide which type of line I'm going to have, a dotted line or a solid line. And remember that solid line would communicate that you have an equal to associated with your inequality. So the dotted line is the less than and the greater than symbol. The solid line is the less than or equal to and the greater than or equal to symbol. So if I look at my symbol, I notice that I have greater than or equal to. I have greater than or equal to here as well. So I'm going to utilize a solid line. So there I draw my solid line. Then from there, I need to decide which way I'm going to shade my graph. So I have region 1 and region 2. I need to pick a point in each region. So I'm going to pick 0, 0 up here. And this time around, I'm going to pick the point x is 1, 2, 3, 4, 5, y is 1. So let's test the point in region 1. So I picked the point 0, 0. So I have negative 6 times 0 plus 3 times 0 is greater than or equal to 12, or negative 12, sorry. So here I have 0 plus 0 is greater than or equal to negative 12. 0 is greater than or equal to negative 12 is true. Now just to make sure that that's the correct region, let's test out region 2 and make sure that it is false. So if I use the point x is 5, y is 1, I have negative 6 times 5 plus 3 times 1 is greater than or equal to negative 12. So I have negative 30 plus 3, which is negative 27. And negative 27 is not greater than or equal to negative 12. It's smaller because it's more negative. So because the point that I have in region 2 does not work in that inequality, I'm going to shade towards the point that does work, which is the point 0, 0. So as I'm shading, I'm noting that every single point that I'm shading over, every single point on this side of the line, is a point that is going to make my original inequality here true. So now let's test these out with horizontal and vertical lines as well. So if you only have one variable contained in your equation, you're going to solve for that one variable alone. And then in order to graph it, because we don't have a slope and a y-intercept here, I want you to just temporarily turn it into an equation And think about what that would look like if it were an equation. So if it were an equation, I would make a table of values. I would know that y is always equal to 4, x can be anything, and I would then go to my graph and I would plot those points. So I would get a vision of what this graph looks like. And from plotting those couple points, I can see that I have a horizontal line here. So this is just to help me sketch it. Once I have sketched some of those points, I can now see that I have a horizontal line. So then from here, I have to decide, do I have a solid line or a dotted line? And because I have the less than or equal to part, I know that I have a solid line. So I'm going to draw a solid line through my graph. Then I have to decide which direction to shade. So again, I can focus on region 1 and region 2. Down here in region 2, I'm going to pick the point 0, 0. Up here in region 1, I'm just going to pick the point x is 0 and y is 1, 2, 3, 4, 5. So then I'm going to go to my inequality and I'm going to test the point. So here it says y is less than or equal to 4. Well, if I test my point from region 1, which is the point 0, 5, what I find is that y is 5 is less than or equal to 4. That is false. So I'm already guessing that I'm not going to shade towards region 1, but let's just test region 2 to be safe. So that's the point x is 0, y is 0. So I plug 0 in for y is less than or equal to 4. That is true. So region 2 is the direction that I want to shade. So I'm going to take my pencil and I'm going to lightly shade all of region 2. So all of these points down here in region 2 are points that will make this inequality up here true, which should make sense because all of these points are the points where y is less than or equal to 4. So in this particular inequality, what I notice is that I only have one variable. So I want to start by solving for that one single variable by itself. So I divide both sides by 2, and I get x is greater than 2. So this is the inequality that I ultimately want to graph. So in order to help me find the line, I'm going to temporarily turn it into an equation, just so I can get an idea of what that looks like. And I know on this particular line, that all x values are 2, and my y values can be whatever I want. So I then go to my graph and I start plotting some of those points. And I start to notice that this particular inequality, the line that associates with it, is going to have a vertical line. Then from here I need to decide, am I going to graph the line with a dotted or a solid line? And remember, the solid line communicates that those points will work in the inequality. If I look at this particular inequality, I notice that I have a greater than symbol. So I notice that this is going to be a dotted line. Then from here, I need to decide which way I want to shade my graph. So I need to look at each region on each side of the line. So I have region 1 and region 2. My point for region 1, I picked 0, 0. My point in region 2, I picked x is 3 and y is 0. So let's test out each region. So in region 1, I'm going to substitute in the point 0, 0. So if I go back to that original inequality, I have 2 times 0 is greater than 4. And I get 0 is greater than 4, which is false. So that's already telling me that region 1 is probably not the region I will be shading, but just to be sure, let's test out the point from region 2. So I have 2 times 3 is greater than 4. So I get 6 is greater than 4, which is in fact true. So what that's telling me here is that I am not going to shade towards region 1, but instead I'm going to shade this region here in region 2. And all of these points here have x values that are greater than 2, and as a result, they make this particular inequality true.